recently, there were phishing attacks where they stole a bunch of NFTs. They stole somebody's Bored Ape that he actually was going to use in a television show. Some actor bought a Bored Ape for like $100,000 and somebody stole it, and he actually bought it back from the thief because he'd already started making a movie. And the Bored Apes, unlike a lot of NFTs, owner of the NFT contributes to you the real copyright to use that commercially. And he had planned to make a TV show of that ape. He needed that ape back. So he did it by phishing, and here's how it works. That's his one. Stole $1.4 million in NFTs by phishing. So we'll make a contract called Wallet. We got a simplified version of it so you can see how you make a contract that is vulnerable to phishing. So that's going to be Wallet. So let's go up here, and I've got a deployed contract, but I don't want that. So I'm just going to switch to the Berlin virtual machine, and now I'm in a different blockchain, a different simulated blockchain where nothing is in there. So I can go here, and Wallet, which is here. I'm just going to delete the old code and put it in fresh in case I'd modified it. All right, and then compile it. And again, just warnings, but no errors. It would turn red if there were errors. So I can deploy it. And I've got Fish and Wallet. So the first one I'm going to do is deploy Wallet. That's the straight up wallet. All right, it deploys down here. And I've got some methods like deposit, withdraw, and owner. That's all it is. This is just a wallet contract. So it has, when you construct it, whoever paid for the gas is the owner of the wallet. Owner is message sender. You can deposit money, and all it does is accept the money. It doesn't do anything else. You can withdraw the money as long as you are the owner. If the origin of this withdrawal request is equal to the owner's address, then it will go down here and send you the money. By calling your function with a value amount. That was one of the ways to send money to you. So that's all this wallet does. You can put money in and you can take money out, but only if you're the owner. And what we're going to do is we're going to make a phishing contract that will seal the money. So let me go back to here. Probably you have to deposit the money and see how it goes. Deploy it. We did that. When you deploy it, it runs the constructor and sets the owner equal to the sender. So let's check that. I'm at 5B3, and the owner is 5B3. Okay, there's zero money in there, but I am the owner, which makes sense. So now we're going to make a deposit of 10 Ether, which is just 10 Ether deposit. Okay, same as before. So I go up here, put in 10 Ether, and then deposit. It works, and I expected the balance to go up, but anyway, let's check the owner. The owner's still the same. What's that? Did I leave 0? Oh, I changed to 0. Thank you. I typed in 10 and it didn't take. Oh, it's not listening to me. Wow. Okay, here. Thank you. Good. Let me do that again. Deposit. There we go. Now it goes up to 10. All right. And the owner is still me. So that's using the wallet as expected. All right. Now we can make a withdrawal. If you do that, you're going to have to copy your account number and then add this garbage. So let's go here, copy your account number, go to withdraw, and I could go down here and put them in separate boxes. I think that's the easier thing to do. I could put them all with a comma separating the first box, but I'm just going to put them in the second box so they're separate. All right, there we are. So there's that, and that is 5 Ether, 10 to the 18. So I should be able to transact. It looks like it's exceeded. Yep, the balance has now fallen to 5 Ether, and I'm now back up to 95. So I can put in money, and I can withdraw money. Now, we're going to attempt a theft. So if the second account tries to withdraw, they're not going to be able to do it. So I go to the second account, and I try to withdraw. I can copy this account number, and I try to withdraw some money. It's going to refuse. It reverts because the withdraw function requires that the origin of the request is equal to the owner, and this require means if the condition is not true, then it reverts. Does not go any further. So that's the way it should be. The wallet will not let anybody else take the money except the owner. But we're going to see why a Fisher works here. So let's, now this one is useful because you get to see the debugger. So let me open the debugger. And if we just had what you could regard as a crash, it reverted. You can view it in the debugger. And let me, it is this thing. And you get there. I think you click the wrench to find it. debug button outlined in yellow in the image above, which does not seem to be true, unfortunately. All right, the debugger is somewhere. I think it's under, is this the debugger? That's the plugin manager, and here's the debugger. Activate. There. Now here's the debugger. All right. And debugger is worth knowing about. On the right side, the require statement should be highlighted, which it is not, unfortunately. Let's try starting debugging. Okay, looks like I'm not having as much luck with the debugger as I was hoping. Debug button. Oh, down there. Okay, there. There we go. There's the debug button. There, now it's debugging. And now see, it's highlighted this command. This is the command where it stopped. And you can see the condition here, which is good. The call is reverted. Here's the owner of solidity state. Here's the details of the step. Here's what you were doing. You were sending this amount to that address. Here's the assembly instruction where it stopped. Here's more information about it. There's the call stack and the call data. You know, just like any other debugger in any other language, you've got all kinds of details showing you this. And the interesting thing for us is we want to find the owner outlined in red here. So if we go here, here is the locals to amount, and someplace in here we are going to find the owner. Let me see if I can figure out how this compares to my picture. Solidity locals, solidity state is where we should find the owner. Solidity state, where is it? Over here. There's the owner. Okay, so you see the owner. All right. And these are the two things you compare, this AB to that 5B. So you can see here what happened, and I've moved this over, it would only let me. All right. This is the address that tried to receive the money, and this is the owner, and they're not the same, and that's why it bounced back. So that's not surprising, but the point of the debugger is you can see it. Let me see if I can get back to the good stuff. Get rid of that. There, it's back here. If I can somehow make this move, but all I'm getting is to tear the things off. All right, I'll eventually get to the one I need. All right, there we go. All right. Now, the problem is we used tx origin in that command. This command here, let me keep closing garbage that's in the way. All right, this command here compared tx origin to owner. And as always, the flaw here is not being careful in using solidity. The tx origin documentation explains what it is. Tx origin is the center of the transaction with the full call chain. And what that means is it's the original source of this. So if I am a man in the middle, if I'm able to do a call that passes through another address on the way, the origin will still be the original address. And that's how we're going to steal the money. We're going to trick the owner of the coins into running something I send them, clicking on a phishing link, which will then forward that request back to here. And it will then believe that I'm allowed to make that request because the origin started from the person who owned the money. So the use of this tx origin is what makes it vulnerable to phishing. So to exploit that vulnerability, we deploy the phish contract, and we're going to have to deploy it with the wallet contract address, which has been true of a lot of these attacks we've done. So if I go back to here, and I've already deployed one of these. That's compile, here's deploy. All right. The contract here, here's the wallet contract. I copy that address. And here's the phish contract, which deploys at that address. And I wonder if it matters who I deploy this as. I think it does not. I'll just carry on. All right. So I deploy this contract. Now I have an attacker contract down here. All right. And the phish contract appears at the left. All right. Now to perform the attack, I have to send a link to the wallet's owner, who will click on a link, and they will then call the phish contract. And so the phish contract down here takes in the wallet address as a parameter, and it calls wallet. And it calls, when the fallback function does a withdraw, in the wallet address. So if you make a request here, this is the constructor, which will just set the owner of this contract equal to the person that paid the gas to come here. And when you call the fallback function, it will forward your request to the wallet contract. And if that original thing started from the owner of the wallet, it will let me have the money. So what I do is I hit the account to the first account, and then in Phish, I hit transact. So this is the point. I have to get the original owner, this person, to execute this Phish contract, which I'll tell them it's something else. You're going to get a free NFT or something. So they go to the Phish contract, and in the set the account to the first contract, right? Then at the bottom left, expand the Phish contract and do a transact. Okay. Right, they're going to send a transaction here, and they don't even need to send any money. If they make a low-level transaction to this contract, it works, and another thing works. And so I think it worked, and how do we see that it worked? If you look, the second account should now have a bunch of Ether. Yep, this wallet is now empty, and the first contract has 95, but the second contract has 105. So that's the point. It withdrew everything. It withdraws the whole balance if you send any money to this contract. So all I have to do is tell them a story, say you can send a request here and I will send you a free valuable NFT. And when you do it, I just forward it back to this other contract and you get your money. So it comes from using TX origin. And you can fix it by using a better decision, a better variable here. So that's TX origin is the problem. And so if you want to fix it, you should use message sender equals owner is one of the ways to fix it. This does not go back to the origin. It does not follow the chain back to the beginning. It sends the very latest move, one step back must be the owner. And nobody can withdraw money unless they're making a direct request from the owner's account, which seems like a better way to do it. So that's all. All right, let me stop this one.